quantum computer is finally gonna solve most of the problems of massive mega industries, from optimal airplane routes to optimal robot pathways. Quantum computer is already accessible for enterprise customers to begin exploring their technology's potential. Quantum computer will solve a wide range of challenges across industries, from optimization to simulation to machine learning, in terms of creating time crystals that can actually reverse in time, created by Microsoft and team. With this last year quantum entanglement based little wormhole that, if you heard about that, it was really fascinating. Quantum computer is on the top-notch level. In this video, I am going to provide 8 mindful simulations of future industries that will gain exponentially massive progress just by quantum computer that will not so far just in 2050. Number 1. Metamaterials and material science. Quantum computer had the potential to revolutionize the fields of material science. Quantum computer excel of simulating quantum systems, allowing researchers to model the behaviors of molecules, atoms, and materials at a quantum level. It means we could artificially create new supermaterials and accelerate the discovery of super materials that could make real progression in every field, like tailored optical properties, electromagnetic clocking, advanced sensors by manipulating and controlling electromagnetic waves. It can calculate materials properties such as electrical conductivity, thermal conductivity, and mechanical strengths. For example, in case of superconductor, just by simulating the behaviors of atoms and electrons at quantum level, and that can help researchers to identify materials with enhanced superconducting properties. It means quantum computers themselves can be used as quantum simulator to model the behaviors of superconductivity. And material science is a vast field, and if we marry quantum computer and material science, then the world will become really futuristic. Next, logistics. Logistics industry could be revolutionized by solving complex problems. This could lead to more efficient and cost-effective supply chains, as well as improved customer service. One of the most promising applications of quantum computer in logistics is in routing optimization. Quantum computer could be used to find the shortest and more efficient routes for goods to travel, taking into account factors such as the traffic congestion, weather conditions, and fuel prices. This could be significantly reduce transportation costs and improve delivery time. Quantum computer could also be used to improve inventory management. Quantum computer could be used to predict demand more accurately, which would help businesses to avoid stockouts and overstocks. This could lead to increased profits and improve customer satisfaction. In addition to, quantum computer could be used to improve security in logistics. Quantum computer could be used to break current encryption method, which could make it more difficult for criminals to steal sensitive data. This could help us to protect businesses and consumers from fraud and cyber attacks. Number 3. Finance. Financial analysts frequently rely on computational models that incorporate probability and assumptions about the performance and market and portfolios. Quantum computer could help enhance these by digesting data faster, running better, forecasting models, and balancing computing possibilities more accurately. They could also add in resolutions complicate optimization problem associated with jobs such as portfolio risk, optimization risk, and fraud detections. Last year's IBM presented research on strategies for gauging financial risk that employed quantum algorithms to outperform traditional Monte Carlo situations. RBS, the Commonwealth Bank of Australia, Goldman Sachs, Citizen Group, and other financial institutions have invested in quantum computing firms. Some are already seeing encouraging effects. Number 4. Artificial intelligence. The first point, I was saying, if we do marriage of the quantum computer and material science, it will revolutionize the world. But if you put AI between both of them, can't imagine what will be the future in 500 years. The ability of quantum computer filter through enormous data sets, simulate complex model, and solve optimization issue efficiently has sparked interest in artificial intelligence applications. For instance, Google working on machine learning that integrates classical and quantum computing, and that it expects these capabilities to function with near quantum computer. Similarly, quantum software startup Jabra has indicated that one of the most promising commercial use for quantum computer in short term is quantum machine learning. Quantum machine learning may eventually give some practical advantages in a variety of domains like artificial driverless vehicles and weather predictions. Future quantum computers may push AI even further. It can improve compute vision, pattern recognition, speech recognition, machine translations, and other technologies to a whole another level. Number 5. Climate change. One way quantum computing could help change is by simulating the behavior of complex molecules and materials This could be used to design a new catalyst for carbon capture and storage, or to develop new materials that are more efficient at converting sunlight into energy. Quantum computer could also be used to model the effects of climate change on weather patterns and sea level, which could help us to more better prediction about the future. It could be used to simulate the behaviors of millions of different molecules at once, which could allow the scientists to quickly and efficiently identify new catalysts that are effective at capturing carbon dioxide from the atmosphere. Quantum computer could be used to design a new material with perfect atomic structure for absorbing and converting sunlight into energy and electricity. And if you see that in terms of twin technology, quantum computer could cool down the city after better calculations and predictions of city heat management by creating clone model. If you don't take any clone model and try to cool down city in real life, these whole subjects is gonna much more complex and impossible to understand. But in this twin technology in quantum computer, you can simulate all of the hot region of city and try to cool down on it. And that's how global warming can be controlled by human. Number 6, chemistry. In simulations of every impossible field, a supercomputer ends. Quantum computer just begin. Quantum computer had the potential to change perspective to see the chemistry. It's providing a way to simulate the behaviors of molecules and materials at atomic level in drug design, materials science, and energy production. This could lead new discoveries in these fields that not gonna ever end. Currently, chemists use computer to simulate the behaviors of molecules, but these simulations are limited by limited of computational power of classical computer. On the other hand, quantum computer could simulate molecules at great accuracy. It could lead that how molecules interact and behave. For instance, quantum computer could be used to design a new drug by simulating the interaction between molecules and proteins. They could also be used to develop new materials with desired properties, such as the high conductivity or resistance to corrosion. Quantum computer could change the technology of quantum understanding by creating quantum materials which exhibit unique quantum properties. These materials have applications in electronics that will evolve itself, quantum computer, and quantum mechanics. Quantum computer can investigate isotopes effects in chemical reactions. It will provide insights into how isotope substitution influence reaction rates and mechanism. Number 7, healthcare. Quantum computing can process vast amounts of genomic and clinical data to provide personalized treatment recommendations by analyzing an individual's genomic makeup, medical histories, and other factors. Google quantum computer Sycamore recently revealed that it simulates a chemical reactions, a significant step forward for the emerging technologies. Despite the fact this particular interaction was rather simple, future quantum computers should be able to replicate complicated molecules and interactions for more precise than classical computer. This could help speed up efforts in healthcare. Effects of medications candidates. Protein folding is another area where quantum computer could help drug discoveries. Protein curve, a startup is already using current quantum computer to anticipate how protein will fold in the body. For ordinary computer, this is a notoriously difficult process. However, employing quantum computing to solve this problem could make building potent protein-based treatments easier in the long run. Eventually, quantum computer may lead more effective approaches to customized medicines by enabling faster genomic analysis to enable personalized treatment strategies tailored to each patient. Companies are already lowering the cost and resources required to sequence the human genome, but a powerful quantum computer may filter through this data considerably faster, making genome sequencing more efficient and easier to scale. A number of pharmaceutical behemoths have invested in quantum computing. Merck's investments arms, for example, invested in Zebra $38 million Series B round in September 2020. Meanwhile, Biogen collaborated with quantum computing software firms OneQubit and Accenture to develop a platform for companies' compounds in order to accelerate medications discovery in early stages. Number 8, cybersecurity. Quantum computer had the potential to disrupt cybersecurity. Powerful quantum computer pose a danger to cryptography technique like RSA encryptions, which are widely used today to secure sensitive data and electronic communications. This possibility stems from Shor's method, a quantum method proposed in the 1990s. This technique illustrates how a sufficiently strong quantum computer could determine prime factors of huge numbers relatively rapidly, a process that classical computers find extremely difficult. To protect the data being transmitted over the internet, RSA encryption relies on this very difficulty. Companies, however, are rising to fight this threat by inventing new encryption method known as post-quantum cryptography. These strategies intended to be more resistant to quantum computer, often by opposing challenge that even a powerful quantum computer would be unlikely to be able to answer. Among the various companies like Asara and post-quantum. At the end, this is just for today, guys. If you want to learn more unique topics that are beyond of human imaginations, please do subscribe and hit the like button. Thank you for watching. Bye bye.